We made it. We made it to the stuff you really wanted to see. Or not. But you'll see on this one, it's, again, take your time with these, especially since this is very new for most of you guys, okay? Take your time. Don't rush it. Don't feel like you have to do it all at once, because I'm not going to, okay? Focus on one part at a time, see how it goes. Now, I need these denominators to match. The problem is that here I've got an x, just an individual term in this denominator, but this one's a binomial with x squared plus 5x. And, well, that kind of sucks, because what we want is, I want to be able to tack on an x here, but they already have x's. Okay, so here's what needs to happen on that. Let's take it, let's separate it, okay? Let's factor that and see what we get. Okay, so x squared, I know I can factor out from both of these terms an x. Okay, that's fair. But if I do that, what happens? I'm left with an x from the first term. One of the x's is left over. And then from the second term, I'm left with just a plus 5. Okay, so that's as factors that I can make that first part, or sorry, that second denominator. So let's take this, and I'm going to rewrite it. And hopefully this will help us to see what is going on. Okay, so I still have 1 in the numerator here, but now in that denominator I have an x times an x plus 5. Okay, does that really help? It does, actually, because I see this x that I factored out. It matches this x from the first fraction. So really all I need is the first fraction. It already has the x matching. I need it to have an x plus 5 match as well, so that it is a common denominator. So I'm going to take that x plus 5, and I'm going to multiply it into this first fraction denominator and the numerator. Remember, if you multiply it by the denominator, you got to multiply in the numerator as well. Now I see that both fractions have denominators of x times x plus 5, but yeah, that numerator's changed a little bit, and that's okay. Now at this point, you could, if you wanted to, distribute right there. Just for the sake of practice, I'm going to wait. But you could if you wanted to, okay? So that plus sign, of course, is going to stay in the numerator, but my new fraction has a denominator of x times x plus 5. And then we were adding the two fractions together. So my first fraction had a numerator of 7 times x plus 5. And then the second fraction had a numerator of 1. So we're just adding those two numerators together, but the denominators match. So we just write in one denominator. Okay, well, now that I have that, I'm going to rewrite this fraction, but I'm going to now distribute the 7. Now I will do it. Some of you, I think, may have done it already, and that's okay if you did. I just haven't yet. So in the numerator, 7 times x would be 7x's. 7 times 5 would be positive 35. And then we still do have the plus 1. Again, I'm doing this one step at a time, so some students would have said, I don't really need to show that step right there. It's possible you may have skipped that step and then went straight into this expression. So again, the numerator, I'm just looking for any like terms to combine. 35 plus 1, that would have been positive 36. So most students don't usually show this step because they can do the 35 plus 1 or they see it. Some do, though, and if you feel like you need to show it, then do show it. It's good to show your work. Okay, now we look for any other factoring from the numerator, because the denominator is already factored, right? But the numerator is 7x plus 36. I don't see anything that can be factored right there. So that's done. Now, don't let the unusualness of how this fraction looks stop you from just keeping it that way, okay? Because again, it's like we see a fraction, we would like to see like 1 over 2, and that's pretty. This one isn't as pretty, but it still works. It's colorful, just not very pretty, but it still works.